So, have you ever wondered if life outside Earth has ever existed? Well, I'm sure it did. This question occupied the minds of scientists, researchers, and just regular people for as long as starting when we first found out that our planet is one of many. I was not an exception. When I was a child, me and my brother used to stay in my grandparents' house for the summer. Back at that time, when I was about 10 years old, we had a little tradition. Every night of the summer, we would sneak out to the top of the roof just to watch the gorgeous view of thousands of stars, count them, and wonder if we were counted by someone else as well. The years have passed, the house with its access to the stunning views was sold, and this little ritual was forgotten ever since. However, till this day, I still wondered, was there anybody out there who watched me and my brother looking at them every single night? Was there anyone who wanted to meet us as passionately as we did? Ever since then, the questions about cosmos and universe have been following me in my life, transforming from speculative fiction to scientific literature and the research papers. Now, I would want all of you to remember that child inside of you, that curious, imaginative kid that we were born along with growing up. While it is obvious that some people might be quite skeptical about the questions about UFOs, for the next 10 minutes, I want all of you to view the story from perspective of that child. So, in 1950s, Enrico Fermi and some of his colleagues were having a lunch at the Los Alamos National Laboratory. Imagine them eating and chatting. Maybe they were also having some wine, who knows? What we know exactly is that they had a conversation about UFOs. In particular, Fermi stated the question that will become quite popular in the future. He asked, "Where is everybody?" Fermi was referring to extraterrestrial intelligence, and this question became the basis of Fermi paradox. Fermi paradox refers to the high probability estimates for extraterrestrial intelligence to exist and apparent lack of evidence. It means that although theoretically we have lots of conditions for complex life to be spread across the universe, we still haven't found any signature of that. How is it possible that, given that the universe is infinite, given the huge number of planets and stars, we still haven't found any signature of life other than us? In fact, we don't have any evidence that life outside the Earth has ever existed. All of our assumptions are based on fictional characters, books, movies, fake news, all of which were proven to be wrong. More than 20 years have passed since its launch, and we still don't have any proper answer to Fermi's question. And as it usually happens, when we don't have answer, we come up with some theories. One of the theories I'll be addressing today in my speech is the probability of life-bearing planets like Earth to be simply very rare. This hypothesis is called the rare Earth theory. And basically, it suggests that for a planet to be habitable and for a complex life to originate, it needs a set of rare astronomical and geological factors which are just not common in our universe. Putting it in more simple words, it means that the complex life in the universe is more like an exception rather than a rule. If that was true, we would be in a very messy station. Why? Because astronomy, and mostly cosmology today, assume the prevalence of extraterrestrial intelligence because we think that our universe is isotropic. For isotropy meaning that it is the same in all directions. It means that if you look at the sky at one starry night on Earth, then you'll see roughly the same picture you would if you looked thousands of light years away. This assumption was made based on Copernican principle, which argues that if something is randomly sampled, then this is the representative of the majority. However, what if I told you that it might not work as we think it does? Let me explain. Thousands of years ago, our ancestors were not aware of existence of other celestial bodies, like stars and planets. They believed that Earth is flat and located in the center of the universe. They simply didn't have enough knowledge and technology to explore the universe, so that is why they made assumptions. And that's exactly what we do today. We believe that our universe is isotropic, even though we don't have any evidence of that. The rare Earth theory suggests, what if our universe is not in fact isotropic? What if a planet A, located thousands of light years away from planet B, is completely different? What if some scientific laws that were proven to work for us simply don't at the other point in the universe? If that is the case, then the probability of life, not even an intelligent or a complex one, but just a simple, primitive life, is extremely low. According to the rare Earth theory, For a planet to be habitable and for complex life to originate, it requires a set of rare astronomical as well as geological factors, just like our Earth. These include, first, a circumstellar habitable zone, also called Goldilocks zone. It is the range of orbits in a solar system within which a planetary surface can support water in its liquid form, meaning that the planet should not be located too close to the star as water will dry out, however not too far away either, as water will freeze, excluding any chances of life to originate. Second, a galactical habitable zone. Now, this one is not as obvious. Turns out that for a solar system to be habitable, it needs to be located in a specific range within the galaxy, meaning that the solar system should not be located too close to the center of it, as the risks of being attacked by other celestial bodies like stars and meteorites rises. However, if solar system will be located too far away from the center of the galaxy, then the solid matter will not form because of the lack of celestial gases. It was studied that only about 1/10 of the whole Milky Way is in fact habitable. Third, a star in a solar system should not be a giant one but not a dwarf either, as the sizes of stars impact directly on planet's temperature as well as radiation levels. And fourth, the satellite in a solar system should not, the sizes of satellite also have a huge impact, so that the satellite should be just like our moon. Meaning it was studied that our moon has a huge impact on planet's weather changes as well as ebbs and flows. Recent researchers have shown that if our moon is located twice closer to Earth as it is right now, then fluids would be 8 times stronger, meaning that our planet would be completely uninhabitable. Fifth, it also requires a chemistry that would be similar to Earth's lithosphere, atmosphere, as well as oceans. And finally, whichever factors have led to the emergence of first ever replicator, which is a molecule responsible for reproduction. It was studied that the first ever replicator should have occurred by a pure chance. Eugene Koonin, in his book The Logic of Case, has estimated that the probability of first ever replicator to originate is 1 to 10 to the power 1018. This number means that even if we search up the whole visible universe, it is still unlikely for us to ever find any signs of life. Moreover, all of these factors above don't even guarantee the evolution of human being and human intelligence, which could have required yet further factors and circumstances. It is completely permissive for life as we know it not to evolve into an intelligent one. For instance, dolphins have a brain structure which is extremely alike to human ones. However, as Line Weaver once said, dolphins had about 20 million years to invent radio telescope. However, they never did. The consideration of the rare earth theory can be quite depressing and may even bring up the fear of one-dimensional loneliness. And indeed, there is something deeply saddening in the silence with which stars answer Fermi's question. In silence so complete that it seems eternal. Thank you for your attention.